So today we're going to be talking about graphing angles and coterminal angles and quadrants on the graph. And so if we go back and just think about graphing in general, if you remember, we have the y-axis and the x-axis, all right? And so, we have our origin. And when we are graphing angles on the coordinate plane, the xy plane, what we generally want to do is you want the vertex of your angle to be at the origin. So that is where the vertex of the angle is going to go. We always start with, if you think about it, an angle is made up of two rays, right? Just by definition, an angle is two rays that meet at one vertex. And so the angle's first ray is always going to be along the positive side of the x-axis, and we call this the initial ray. So this is kind of where the angle starts, all right? And then when we talk about the other ray of whatever angle we're dealing with, when we're graphing angles on the coordinate plane, so the vertex is always going to be at 0, 0, the initial ray is always going to be the x-axis on the positive side, and then wherever the angle, the other ray of the angle, we call this the terminal ray. So you have your initial ray and your terminal ray. Remember, terminal like ending. The terminal at the airport is because that's where your trip ends, right? Terminal is another form of an illness that ends in death, and things like terminal means to end. So the start of the angle, the initial side, and the terminal ray of the angle. In graphing angles, we always go counterclockwise. Always. And in fact, it is because we measure angles this way, we always have circles spin in this direction. It's why the quadrants of the coordinate plane are numbered in the way that they are. 1, 2, 3, and 4. I don't know if it always felt like the numbers of the quadrant were kind of backwards when I first learned them. When I first learned my x and y coordinates and how to plot points and stuff, I thought it was really weird that it went 1, 2, 3, 4. It felt very backwards to me because, clockwise, when we read clocks and things like that, go in the other direction. But this is actually originally how angles have always been measured in mathematics on the coordinate plane. So you have your vertex at 0, 0, your initial ray here on the x-axis, and your terminal ray on the other side, and it travels counterclockwise. So if we think about that, certain angles fall into different quadrants on the coordinate plane. Between 0 and 90 degrees is in this first quadrant. And that's in degrees. And then in the second quadrant, it goes from 90, technically 90 is not in either of the quadrants. 0 is not in either of the quadrants. They're on the axes. So between 90 degrees and 180 degrees is going to be in the second quadrant. From 180 degrees to 270 degrees is in that third quadrant. And then between 270 degrees and 360 degrees is in the fourth quadrant. Now, this is important because we want to realize that giving us an angle tells us where we kind of land on the coordinate plane. It is important to note that we can do this in radians as well. We want to think about radians. So again, if you start here between 0 and over here on this side, we said half the circle, halfway around the circle was pi radians. So if I'm going around this half of the circle and I go halfway, that would be up here at 90 degrees. So 90 degrees is actually pi over 2 radians. So between 0 and pi over 2 So 0, we started here. Between 0 and pi over 2 is in the first quadrant. Between pi over 2 and pi is going to be in the second quadrant. Between pi, and then what you have to realize is each one of these quadrants is half pi radians, half of a pi radians. And so that means that this would be between 3/2 pi. So between pi and 3/2 pi, and then between 3/2 pi and 2 pi are going to be the angles in the fourth quadrant. And so we spin going in this counterclockwise direction. So there's a couple of interesting things about the fact that when we graph on this coordinate plane, what it opens up is an ability for us to go angles that are larger than 360 degrees. Because when we talk about angles on the coordinate plane, we're actually talking about, spinning something around the coordinate plane. So you started here, and then how far did you go around before you actually stopped this ray? So you can actually take multiple trips around the circle and get angles that are actually larger than 360 degrees or larger than 2 pi radians, depending on which one you're measuring in. It also means that I might not want to spin counterclockwise. Maybe I actually want to spin clockwise. And so if I have whatever it is, and this is used a lot in things like wheels and gears and any of those types of machinery, this is used a lot in calibrating those and programming and designing them. So if you want something to spin counterclockwise, you can give it a degree or a number of turns to spin counterclockwise, but what if you want it to spin clockwise? And so that actually opened up this idea of I could have negative angles. So it's important to note that we start here at the x-axis and spin counterclockwise if we have a positive angle measurement. But if we have a negative angle measurement, that just means that we're going that distance clockwise instead of counterclockwise. So you can have negative angles. So for example, if I was asked to graph, let's say I was asked to graph the angle 75 degrees. Well, I know I want my origin to be my vertex, so then my initial side of the angle is going to be here at 0, so that's where my angle is starting. It is positive, so I'm going to go this way. And I know that this is 90 degrees, so 75 is less than that. It's going to be in between here somewhere. If I think halfway of 90 is 45, so half of 45 is like 22, and so that's going to be like 67. It'll be a little further than that. So 75 would be around here somewhere. And so this angle would be about 75 degrees. What if I was asked to graph pi over 6 radians? Well, let's see. If this is 0, I know I want my vertex to be at the origin, and then my initial side is going to be over here. Let's see, pi over 6. Well, I know this is pi. So the one cool thing about radians is it's fractions. Everything's fractions. So if this is pi over 6, that's 1/6. That means I want to take this half of a circle and cut it into 6 equal pieces. Well, let's see, this would be halfway. So then I just need this to go into, 3 equal pieces, and this to go into 3 equal pieces. So that would be 1, 2, 3, 4, 5, 6 equal pieces. And 1/6 of it would actually be this one over here. So I can break up this circle into fractions. So this would be pi over 6 radians. And so you can draw and graph these different angles. But let's say that we wanted to look at negative 30 degrees. Well, negative means that I'm going to be having my vertex at the origin, and I'm starting here on the x-axis, but it means that I'm going to be spinning clockwise instead of counterclockwise. And I know this is 90 degrees, so if I cut this into 3 equal pieces, 30 should be about 1/3. So this would be 30 degrees, but it's going in the counterclockwise direction. So this would be negative 30 degrees. Let's say I wanted to graph 4 pi radians. Well, if I have my origin as my vertex and I've got my initial ray here, I know that if I go all the way around, that's 2 pi. So I want to go all the way around, but I want to go all the way around twice. So I've got my initial ray, and then I'm going to go around once. That would be 2 pi, and then 3 pi, and then 4 pi would actually end right where it started. And so that would just be 4 pi radians. So you can go around more than once. And so you get these angles that are actually larger than 360 degrees or negative angles. And in the past, that wouldn't have made any sense in any context that we were aware of. You couldn't really draw an angle that was more than 360 degrees. Or even 180 sometimes if you really thought about how to draw it. And then negative angles would have had no context for us at all if we were thinking about polygons and triangles and things like that. But when we talk about graphing angles on the coordinate plane, we can include those larger numbers and the negative numbers. Now, what this also causes is it causes there to be angles that technically look the same, but they have different measurements. We call these coterminal angles. And if we think about that vocabulary that we were just talking about before, when we're graphing an angle, the initial ray is on the x-axis, and where the angle ends is its terminal angle, or its terminal ray, I'm sorry. And so when we talk about being coterminal, that means it's two angles that actually their terminal ray is in the exact same spot. So for example, if I had a 45-degree angle, my initial ray is here, 45 degrees exactly halfway between 90 degrees. So this would be 45 degrees. Well, then what if I wanted to graph 405 degrees? So let's think about that for a second. 405 degrees. Well, if I've got my initial side here, that's more than 360. So I'm definitely going to go all the way around. So that's 360. And then I'm going to go another 45 degrees, because 360 plus 45 would be 405 degrees. So when I'm drawing a 405 degree angle and a 45 degree angle, the blue one went around one full time before it stopped here, and the 45 degree angle just went straight there and stopped, but they did both stop at the exact same place. That's why they're coterminal. They end together. They end at the same place. So these would be coterminal angles. In order to find coterminal angles, all you have to do is think about, well, what is a full circle? All coterminal angles are just a full circle away from each other. So you can always find other angles that would be coterminal angles just by adding or subtracting 360 degrees. Or if you're in radians, you can add or subtract 2 pi radians. Sometimes they can ask these questions in lots of different ways. They can give you an angle that is between 0 and 360 and say, find a positive coterminal angle. So just add 360 to it. If they say find a negative coterminal angle, well, then you just subtract 360 degrees from it. Sometimes they'll give you a really big angle, and then they'll say find a coterminal angle that is between 0 and 360. Well, let's say they gave us 1,000. Let's say they gave me 1,065 degrees, and they want me to find a coterminal angle that is actually just between 0 and 360. Well, all I'm going to do is start subtracting 360 from it and see what I get. So 1065 minus 360 is 705. Well, that's still not between 0 and 360. So I'm going to subtract 360 again. And I got 345 degrees. So that means the angle between 0 and 360 that is coterminal with 1065 is 345. So that angle would be down here in the fourth quadrant somewhere, right? It would be 15 degrees from being all the way at 360. So, 1,065 is going to go around 2 full circles and then end here. And so you can use this idea of coterminal. I can find coterminal angles that are positive or negative just by adding or subtracting 2 pi or 360 degrees.